Hi everyone. This lesson we're going to look at solving radical equations graphically. We've done a little bit of work with radicals for a big part of the chapter so far, but we haven't done any equations. We've done expressions like, the square root of 40 plus 3 square root of 5. And we've been simplifying expressions, but not equations. We've added radicals, subtracted, multiplied, and divided radicals. But now we're getting ready to address the question of the equation. How do you solve an equation? So maybe it's not constant. It's got x in it and it equals 7. That is a different ball game. We're going to start out by solving them with graphing. So we've never solved radical equations before, but we have used the graphing method. So for much of this, it's going to feel kind of familiar. We're just going to solve a different type of equation, but we're going to use the same method of solving by graphing. So what does that look like? Well, on page 368 of our book, you're going to see a worked out example. And they've already started solving it. So this is the first time we've seen this. Here is our radical equation. Now, we've done this before, where I had you do it in 3 stages. The first stage was to show me your equations that you're graphing. So you take the original equation and break it into 2 graphs. The graph of the left side and the graph of the right side. And we're looking for an intersection point. So the second step is for you to sketch a graph for me. Okay, but we're going to let the calculator do the graph. So let's pull it up. All right, so you can see I pulled up the equation, and so y1 I'm going to start to type in. I've got minus 3x. I got the first equation, enter, and the 4 is y equals 4 is the next equation. Next, I'm thinking about the graph. Now, one of the challenges with solving by graphing is the window. Sometimes the window is not obvious and we have to hunt, do some trial and error, and try to guess and use some clues to get a good window. One of the clues, though, I'm seeing right here is y equals 4. So we're going to have a horizontal line come across at 4, which is definitely between 10 and negative 10, or negative 10 and 10. So the y numbers, I think, the negative 10 to 10 on the y's might be a good start. And the square root equation is kind of small numbers, so I'm hoping that the standard window will be fine. So that's a good place to start. Number 6, the standard window, negative 10 to 10 on the x, negative 10 to 10 on the y's, and we'll see what happens. All right, sure enough, it's showing everything we need. We're seeing the left side and the right side graphed, and they intersect. And you might recall that the calc command above the trace button will find that intersection point. So we go second, trace. That opens the calc menu, and number 5 is the intersect command. Now it's going to ask a few questions. Just for emphasis, I'm going to move off that point just to show, okay, the questions are being asked. What's the first curve? And it suggests y1. So we hit enter to say yes. Now, what's the second curve? And it's shifted to the other curve, and it's suggesting y2. And we're going to hit enter to say yes. And now it needs a guess, which, as long as there's only one intersection point, doesn't really matter a whole lot. And it found the intersection point at negative 2, 4. So we definitely have an intersection point. It's been calculated. And we're going to take this off of our calculator screen. And for me, you would sketch it on paper and pencil so I can see how you thought, what you thought was your solution. Okay, so let's do that. So it starts around, I'm just trying to remember, it starts around positive 3 and it goes back negative 2, 4. Okay, so for our sketch, we got the axis coming in, and we had the red line coming across like that. The square root graph, 1, 2, 3, it was right around here, and it kept growing up and crossed there. And that intersection point, I'd like you to label it so I know what you're thinking of, is -2, 4. Now, with this method, the third thing you're going to do for me is you're going to explain your solution. We're trying to solve this. Now, this is not a graph, this is an equation, and it's an equation about x. So the point is not the solution. This is not the answer. That's the intersection point. But the answer is about solving for x. What is the x number that makes this true? So we'd finish off by saying x is -2. And if we were really curious, we could check this algebraically, but the calculator has solved it and we are all done. But just for curiosity, let's check. So we can put 10 minus 3, and I want to see what that square root equals. So when I check, I'm going to plug in the -2 answer that we got. And we're going to check with the math and see what happens. So this is 10 plus 6, which is 16, which equals 4, and that's what it's supposed to equal. So it definitely does check. Okay, so this worked example on page 368 is where we started. You can kind of study that in the book in more detail. But let's go on to the next page, 369. Now you've got like 3 different graphs on this page, and I'm going to go out of order and change things around a little bit. So on page 369, I want you to find number 24, and it is a cube root equation, but I don't want to solve the cube root equation. Let's solve a square root equation. So, first thing to do, when you're solving for me, tell me what you're graphing. So we're going to split the equation into 2 graphs. 8x plus 3 equals y1, and y2 is going to be 4. Now the second step is a sketch of the graph. Okay, so let's have the calculator do its work. And we'll go back. We're going to start over, and we're going to type in the square root of 8x plus 3. Now remember, I switched the problem. It's not a cube root, it's a square root. And just as a coincidence, the other side equals 4 like the previous problem. And also with these small numbers, I'm thinking that the standard window will work. So I'm going to leave these 10s on here and hit the graph, and hopefully it crosses. And sure enough, we see an intersection. So let's calculate that intersection point. I'm going to scroll down to number 5, hit intersect. So it asks me all the questions. What's the first curve? It's blinking on it. I'm going to accept that. It's blinking on the second curve. I'm going to accept that and then run the guess. And I get a solution. 1.625, 4. That's where both graphs are at the same point. So let's transfer that graph to our sketch and then explain the solution to our equation. So we have the x-axis and the y-axis. We had one of our curves going something like that. We had another curve. You don't have to use colors if you don't want, but I have them, so I'm going to use them. And we want to identify that intersection point right here, which was 1.625, 4. All right. And maybe you could add the window. That would be helpful too, so I know what window you're looking at. Lastly, we just need to interpret the graph. The graph is trying to help us solve this equation, and the equation is about x. So what we're looking for is x. Well, the x is equal to 1.6. And it does say rounded to decimals, so we'll say 1.63. There's our solution. That's the third step, where you tell me what the solution is. Pretty straightforward. You guys have done this several times on different types of equations, and now you can solve square root equations with this graphing calculator method. All right, let's try another one here. I'm still on page 369, but I'm going to go back up to problem number 23. And I'm basically doing this page backwards. So we did 24, now I'm going to do 23b first. It also is a square root problem, and we're going to solve it by graphing. So let's start. Step 1, get our equations figured out. 41 plus 5 times the square root of 2x minus 4. And y2 equals 11. All right, we're good there. Let's get our equations graphed and see what we're facing. So I'm going to clear these both because they're different this time. And so we'll have 41 plus 5 times the square root of 2x minus 4. And the other one is 11. And I'm going to graph. Okay, I'm still using the same window. The 10s, hit the graph. Waiting. 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 Nothing. Wait, what's going on here? Typically when nothing goes on, when the graph shows only one curve or nothing at all, like this case, that means our window is not correct. It's not showing our picture. Now I did that on purpose just to kind of emphasize the fact that you got to adjust the window sometimes. Now how are we going to adjust it? We need a lot of clues here. And one of the clues is right here. This is 11. So if I go from -10 to 10, I'm already too small for 11 to show. 11 is going to come across higher than that. The other one has a 41 in it. So if I add 41 to the graph, it's going to be way bigger than 10. It's going to be up in the 40s. Okay, so we're going to have to make some adjustments to this window here. So let's go back, open up the window, and the y numbers definitely we need to start playing around with. Didn't seem like anything happened in the negative y's, so let's start the y's at 0 and go up to, let's say up to 50 on the y's. Because 41 is being added to this other y, so that's going to be kind of high. So let's see what happens. Let's graph. Okay, clearly we got our y equals 11 way down here at the 11. And up here is 50, and there's a little something weird going on there. I'm not quite convinced that I'm really seeing this thing right. So, but it doesn't seem like we need these negative x's. So I'm going to adjust the window again. Let's take off the negative x's. Let's make the y's go even higher. Let's say 80. And I'm going to count the y's by tens. And then graph. All right, definitely I'm seeing the expected square root graph in blue there. And I'm seeing y equals 11 here, but I'm not seeing any point of intersection. what is going on here. So, just out of curiosity, let's make the calculator try to find the intersection. Maybe we're just not seeing it. And so I'm going to go second calc, go down to number 5, do the intersection. Now it's asking for the first curve. Now I want to show you something though. Sometimes this happens. The calculator comes on and asks for the first curve, and notice the y is blank. The cursor isn't on anything, so it doesn't really know what you're selecting until you've got a point and a cursor on a curve. So you sometimes have to move the cursor around, and now that I've got a cursor on the graph, it knows that I'm talking about this y1. So now it'll accept it. I hit enter. And the cursor is on the red one, so I can accept that. And now I'm going to enter a guess. And whoa, gives me an error. Something weird is happening. Let's quit. Go back to the graph. So let's at least draw the graph. And remember we went on this window. So I'd like you to tell me what your window was when you're sketching. And so it was 0 to 80, 0 to 10. So we did 0 to 10, and we went 0 to 80, and we had one line coming in here that was around at 11, and then we had the other one starting right around here, and it went maybe a little lower. It went like that. What's happening? Well, when we look at the graph, there is no intersection. Now we're using the graph to help us solve this. We're trying to solve an equation, but if there's no intersection, it's trying to tell us something about the equation. Well, if there's no intersection point, then there's no time when y1 equals y2. It's not happening. These two things never equal each other, which means this equation has something wrong with it. If there is no intersection, the solution does not exist. So there is no answer. Now, when we go into 9.6, we can actually solve this by algebra and see that dilemma take place. But we haven't studied how to do this algebraically right now, so we're just trusting the calculator. That's really all we can do with it. So if there's no intersection, then there is no solution. All right, let's go on and try another example. Now, problem 23, part A, is a cube root equation. Now, during 2020, this COVID semester, we're not going to get really crazy with the cube roots. We're going to focus primarily on square roots. But it is quite easy to solve these equations with the calculator. So let's solve a cube root one with the calculator. See how that would take shape. So I'm going to start defining my equations. So I got the left side and the right side figured out. Next, I'm going to put them in the calculator and draw a picture. Now, we haven't done much graphing with cube roots. So, they are different than square roots. They have different characteristics, but we can still graph it and see. So I want a cube root, not a square root, so I cannot use the second command on second power to get the square root. I need something new. And I'm going to go to the math button. In the math button, I have all the radicals. Number 4 is specifically for cube roots only. And number 5 I could use if I type the 3 first. It is, number 5 does all the radicals. But just for simplicity, I'm going to come down here to number 4 and make the calculator pull up the cube root, and it puts it in the equation. And we'll just type in 2x minus 1. Enter that, and then we're going to enter 5 on the other side. Okay, now y equals 5. That's going to cut across horizontally at 5, which is definitely in between 10 and negative 10. So maybe the standard window will be okay. So let's go down to number 6. And because you remember, I have a kind of a crazy window from before. So I don't want to retype everything. I'm just going to do the standard window, and it will recalculate the window. Okay, so there is the cube root curve. It looks a little different. It has a different domain, has a different shape, and it doesn't cross. Shoot. Do not have an intersection point. Okay, well, but I do see that the cube root curve is going up. So maybe it will cross eventually, but x equals 10 right here, and it's just not far enough. So I don't think we need any negative x's. So now we're going to start messing around with the window. We don't need the y's bigger than 10 because it's got to cross this y equals 5 line. So I think our y's are good. But it's the x's that we need to adjust. So I'm going to start at 0 for my x. And let's go up to 50. And the y's, let's keep them there. See what happens. Oh! The graph comes in, but it doesn't look like it quite crossed yet. So I don't have an intersection point, but it's really close, which was telling me my x's, making them more x's was a good clue. So I'm going to add some more x's. Let's go all the way up to 100. Counting by tens, and try the graph one more time. All right, clearly it crosses. We have a good intersection point. So we can go second calc, go down to number 5, do the first curve, second curve, and guess. And there I've got a solid intersection point at 63.5. Okay, now I have to remember that we went from 0 to 100, and we went negative 10 to 10. So when I graph it and 63.5, let's sketch that. That's your second step. Let's come over here and sketch it. So we had the x-axis, negative 10. Oh, I didn't actually do negative 10. I had switched that. I went from 0 to 100, and the y's were negative 10 to negative 10. And then the horizontal line, that's easy. That went in right at 5. Well, that's not negative. That's positive 10. And then the cubic curve. Now, we don't know a whole lot about cubics, but, you know, it just did something a little weird, and it crossed. Oh, man, that's messed up. It eventually crossed something around there at 63.5. Okay, so this is step 2. Get the sketch of the graph. Step 3 is explain. What does this point tell me about solving that equation? Now, the point on the graph is not solving the equation. The equation needs to be solved for x. So the x number that we want is x equals 63. That's our solution. We're all done. Now, the calculator has done all the work for us and given us what we need. We could check it just for curiosity, and algebraically it might be good to practice checking just to know that when we do the equations later with algebra, you can have that skill of checking. So we would be checking the cube root of 2 times x minus 1, and we want to know what it's going to equal. We hope it equals 5. So our answer was 63. And we want to check this to see if that works. So as I'm checking, it's a cube root. 2 times 63 is 126 minus 1, which equals the cube root of 125. And the cube root of 125, you may remember from earlier in chapter 9 when we did cube roots, that it has an exact answer of 5, and that's what it's supposed to equal. This checks. All right, so there we go. We have a good solution to this thing. So you got a couple of examples here worked out showing how to solve radical equations with your graphing calculator. Practice that, get really good at that. That's going to help you when we solve the equations with algebra. Because when you solve it with algebra, you can use this graphing method to check those algebra answers. Anyway, study hard on this, and I wish you the best success on it.